Okay, this is your video hint to help you get going with question number 6. As always, remember to read the entire question. Be very careful because they don't always give you the equations sentence by sentence. The most important thing at the beginning is read through it and then pay close attention to the last sentence. They want to know the length of time that Kathy and Brian are driving on this trip. So I used K and B. K is the number of hours that Kathy drives. You got to keep that in mind. It's how long she's driving by hours. Same thing with Brian, the number of hours that Brian drives. All right, so if the number of hours they drive is 12 together, that is actually going to give us our first equation. Be careful with the 750. We can't work on miles right now because the only thing we know about is that Kathy, together with Brian, they're both driving a certain amount of hours. We don't know if she drove 1 hour and he drove 11, or if they split it down the line and they each drove 6 miles or 6 hours. We don't know that. Okay, the only thing we know is that together they did this trip together, Kathy plus Brian, the number of hours each person drove equals 12. So that's our first sentence. The second sentence we have to think about a little more closely. We know the number of miles they drove was 750, and we know each person's speed. So if you remember learning about distance and time and all that good stuff, you know that if Kathy is driving the first part of the trip and she is going 65 miles per hour, let's say Kathy just drives for 1 hour. That means 65 times 1, she would be able to cover a distance of 65 miles. The thing is, we don't know if she only drove for an hour. She might have driven for 2 or 2.5 or 3 or 3.5 hours. In that case, you would have to make sure you multiply the number of hours she drove times her speed of 65 miles per hour. So that takes care of the 65K. And let's see, Brian drove the remaining part of the trip at 55 miles per hour, so he was a little bit slower, but you would still do the same thing. The speed he was going times the number of hours that he was actually driving, which again, we don't know that yet, would give you how far distance-wise they were able to travel together, which we know is 750. So hopefully that makes sense to you, how we came up with those equations. One more hint I could give you is the fact that the K's line up, the B's line up, the equal signs line up, even the constant terms line up. So this is a great question to use elimination on. The only problem is if you add right now, no variables get eliminated. So you'll have to do some multiplying. I'm going to suggest to get you going that you multiply this top equation by, and it would have to be a negative number. If you want to cancel your k's, you would multiply it by negative 65. If you would rather cancel your b's, you'd have to multiply the top equation by negative 55. Just make sure that whatever you use, whatever your game plan is, you would need, if you have a positive 65K, make sure you end up with a negative 65K on top. Also, one thing I noticed about work from last week, we are always remembering to distribute this value all the way through. You can't just distribute it to the variables. You have to make sure you're distributing it through even to this constant term. We're not changing the equation. It's kind of like a fraction. If we have the fraction 1/2 and we want to multiply by 3 on the bottom, you have to multiply by 3 on the top to keep the value of that fraction the same. It's kind of the same idea of what you're doing when you multiply one of your equations. Every part of that equation has to be multiplied by the same factor. Otherwise, this equation ends up being or having a totally different value. That would be like taking a fraction and only multiplying the denominator by a certain number. We know that 1/2 is not going to be equal to 1/6. It has to be multiplied top and bottom. So in that kind of the same logic. That's why this multiplier always multiplies against the entire equation. Every single part and piece gives you the new equation that's actually equivalent, just looks different, and then it'll allow you to do your elimination. So as usual, if this helps, great, finish it up. If you're still stuck and you need more help or you get stuck along the way, just give me a quick